everybody. Can we get a hand of applause for our MC Juan, who's been awesome today? So much work goes into this conference, and yeah, really appreciative of everybody being here and all of the support that goes into it. So as we discover this, and I'll talk about some of my goals here, is every now and then, seeing a merge request or a pull request, I'd get a suggestion, and I'm like, oh, since when has that been in JavaScript? And someone's like, oh, it's been in for 3 years. It was added in, 2022, 2021. So there's two reasons that I kind of want to discover or talk about this. One is so you understand the process, so you can understand like what's coming, how do I look that up, how do I see what's to come, and then number two, just to kind of know, what's new and should it help your developer experience and kind of how you work from day to day. So first, I'll just touch a little bit about me. I am an engineering manager at General Atomics CCRI. We do a lot of geospatial analysis, real-time analytics, and historical analytics on maps. We are hiring. All of those recs are from the last week due to expansion. And one of the ways that I kind of think of what we're doing is, no matter where you're from or where you currently are, those are shipping lanes all over the world. In one way or another, we're connected some way, if you will. And then a tiny bit about me. I moved to Utah in 2019 from New Jersey, but we are still New Jersey Devils fans. So even though Utah is a hockey team now, we're gonna, maybe not switch over yet. So let's talk about ECMAScript 2024, also sometimes called ES15, the 15th version of the standard. But that notation's pretty much going away, and now, typically it's just with the year, if you will. So first, why on earth do they call it ECMAScript and not JavaScript? And part of that is because when Sun was acquired by Oracle, they have the either the trademark or the rights to the word JavaScript. So that's why the standard's different. Initially, the European Computer Manufacturers Association, now called ECMA International, they would oversee this, but now pretty much that it no longer stands for anything, if you will. So they have a bunch of standards, the standards committee, ECMA International. They have ECMA 262. That's the one that you're probably familiar with, the JavaScript standards, if you will. It has a yearly release. That could change, but for the past 8+ years, it's a yearly release, so I doubt that's going to change anytime soon. But they also maintain other standards, so like C#, the JSON standard, etc. So, you might ask yourself, well, why on earth do we even need this? Like, what's the benefits of a standards organization? And that's a great question, right? So there's a whole bunch of goals that they have. I'm just going to highlight some of them. So one of the things is you want consistency across different environments. And why do you want that? You want to make the web as predictable as possible. Code that you wrote 5 years ago, code that you wrote for a mobile browser, a desktop browser, etc. It behaves in the same way, and you have that, those benefits. So interoperability. So it doesn't matter who wrote your JavaScript engine. Ideally, the language should work the same way regardless of the browser if they're implementing the standards. And then there's other benefits as well. So like different collaborations. So obviously the implementers, the different browsers, other developers, and it's funny, when people think about DX and developer experience, sometimes it's like, well, if I like it, that's a good developer experience. But, balancing all of those different stakeholders, who wants what, and then, just making the language well-rounded. And then most importantly, or at least I think most importantly, is the documentation and references. So there's, common docs, so you know how things should behave and how to use it. So this standards committee, TC 39, technical committee 39. And what on earth do they do? So now one of the things that I like is everything's on their GitHub, so you can go through, you can see all of the history, the different discussions, the output from their meetings to see how they got to anywhere on any single feature in the language, if you will. So they're going to maintain JavaScript, and the whole goal is trying not to break the web. So obviously, you're going to add latest and greatest, but you want to selectively deprecate things, make breaking changes just to keep the web working. So like some page written 12 years ago, you don't break that application even though it's not thoroughly maintained or it uses a less popular framework today. And so who are the groups that are involved? Typically the different implementers like Mozilla, Apple, Google, companies that use JavaScript, different people from academics, and then end users like yourselves who will be developing the languages, and then different, they'll pull in different subject matter experts. So I'll talk about temporal later, and they brought in time experts that are experts on the time standards just to make sure like the workflows make sense. And like, I'm not a time expert. I couldn't think of any workflow I couldn't do with the new temporal API. However, they have, people who are subject matter experts in different areas to weigh in on these to try to figure out as many use cases as possible. And how exactly do they operate? There's typically 6 meetings per year, and this is kind of important because you'll see one that's stage 4, and you'll think, well, why wasn't it in the standard? And it's sort of like there's a window of when things need to go in. So they'll have those 6 meetings per year, and then you can see the outputs on their GitHub, if you will. And it's a very transparent process. Anyone can make a proposal. You can make a proposal right now. And it'll start off at stage 0 and kind of balances the concerns across the different, stakeholders, whether it's developer experience or just how it performs in different browser implementations, if you will. And then, you'll have vetting that will take place as those proposals evolve. And keep this in mind, right? Especially when you see proposals in stage 1, not every proposal makes it to stage 4. Not every proposal is going to ship. There's proposals that have taken over 10 years. So like just because it's like just got to stage 3, don't think it's going to be in next year. It might be, it might not. So like it takes time, and there's a ton of discussion and vetting that causes a feature to go live, and that needs to happen. And also a proposal, typically they advance through the stages and eventually get there, but they can be withdrawn. You might lose the champion, etc. So like just because you see a proposal in stage 2 and you're like, this is really awesome, can't wait to use it, it'll eventually be there. We have some hacky polyfill. It may not, it could get withdrawn. So like use that as a word of caution. And anyone can submit feedback. You don't need to have any special job group, special GitHub role. You could just go on there, submit feedback of like, hey, this use case seems weird. You should structure it like this. However, it's most impactful before stage 2.7. And I'm going to talk about the stages, but like before stage 2.7, it's still evolving. The API is still changing, so that discussion can actually change on how it works. After that, it's locked down. And even though you might have some great points in the discussion, it's kind of too late in regards to how ironed out a given proposal is. So let's talk about the stages. There's technically 5 or 6, but you'll see them as I go through them, if you will. So stage 0 is one that you can make right now. It's a new proposal. They're not considering it yet. Anyone can make one. And the whole goal of stage 0 is just, what's an idea, an improvement that could improve the language, kind of describe it, and then add some possible challenges if you can think of them. Stage 1 is where it gets interesting. So that means once stage 1 happens, it'll be on the GitHub page. It's now owned by TC39, the technical committee. They're going to review the problem space. And then in order to get there, whoever wrote it, there'll need to be a champion. So that can be one or many people. And these are the people who are going to champion that proposal and try to take it the distance. Now, mind you, you'll see the champions change. Certain ones have taken 10 years and have gotten in. To stick with it for 10 years, that takes a lot of commitment, but that's why the champions can change. And some, people just stick with them. The champions have been the same and they get into the standards. And another thing, once in order to make it to stage 1, you'll have to kind of outline the problem space and then also talk about concerns with implementation. And and those will all be on the public repo, if you will. And then one other thing about stage 1 is typically you'll talk about prior art, if you will. It might be called something else. That's how I think of it. And it's well, what do other languages do? How do other groups do it? So for example, currently this exists in Lodash. We could do that. This is how they do it in Java or Python. So just to talk about other ways that a similar idea has been done before, if you will. So stage 2 and 2.7 comes next. Stage 2 is typically referred to as like a draft. So kind of, what's it take to get there in regards to the entrance criteria? You'll need to have the high-level API described, so you kind of know how it's going to look, examples of the usage, the spec, semantics, etc. And then, if we think about this is when, for stage 2, you start having that detailed solution, which will be identified and kind of chosen by the committee, if you will. It's still in draft, so like it still may change. So like even if there's an experimental polyfill to play around with it, you probably don't want to use that in a ton of production code. I'm going to give at least 2 warnings of that, but like if, really heed the concerns of the committee, if you will. You really don't want to use things in code that you really care about until after stage 3. And I personally would wait till stage 4 when it's in the standard. And then because the design's not fully yet standardized in stage 2, they can realize they missed a use case. There can be performance issues. Any other unknown factors can tweak it, if you will. So might require some or a bunch of rework. And there'll be experimental implementations in stage 2, but like those are not for prod. Even if great developers worked on it, a great company worked on that, a lot of times they'll give you a warning, this polyfill is not for prod. You should probably listen to them because it's just to have a working, living, breathing prototype to kind of interact with it, if you will. And then they'll also be talking about investigations into different APIs, how it integrates. 2.7 is when it starts getting interesting, so that's the candidate, right? So it's hard to write the implementation just from a spec sheet. So TC39 has a giant list of tests. They're incredibly comprehensive. And that's the main point in regards to stage 2.7. 2.7 wasn't always a thing, if you will. So pretty much the proposal's approved in principle, and it's going validation. Now these tests, so the goal is like there will be no additional work without feedback from the tests. So seeing like, hey, did certain tests not pass? Were certain tests imperformant, or just early examples of usage, if you will. So ideally, at 2.7, the API should be ironed out. It's not going to change that much. And you'll have the syntax, the different APIs, and then the reviewers, you'll have assigned reviewers, if you will, of the group, and they'll approve the current specification text. And the whole goal is with these tests, if you will, they're going through that rigorous development of those tests. However, whatever the feedback is, that can always change the proposal, if you will. And that will kind of aid in their development in regards to it passing those tests. Now, stage 3 is when it's recommended for implementation. So this is the TC39 committee saying, hey, look, we want this to go into the standards. If you're a JavaScript engine supporting a browser, start implementing this. Now, here's the key, right? Even though they're saying, hey, we want this in the standard, we recommend it for implementation, you'll see that yellow twice, and you'll see it on different proposals. A lot of times the proposals, they're experimental, right? So they want you to try it, report bugs. It may not be as performant. There might be some edge cases, et cetera. So realize that even though something looks pretty complete, pretty awesome in stage 3, it's, use it with caution, if you will. And I would probably say immense caution. But once it's in stage 3, it's very unlikely that there'll be a ton of changes. Now, there could be some changes. There's been different performance issues identified late in the process. An engine tries to implement something, they realize it's much slower than they realize, it's not performant, and they have to go back and change it. But ideally, it's pretty ironed out at that point in time. And the whole goal to get here is there's a ton of, testing, and you need to have at least 2 of the major JavaScript engine implementers to have implemented it, if you will. So at least 2 of them need to implement it, and then and then that's when we'll start getting different insights from the use actual in web applications, etc. So finally, my favorite stage 4, is when it's finished. It's ready to go, and it's going to be included in the standard. The second it's stage 4, even if it's not in the standard yet, it'll eventually get in one of the standards, and I'll show you that in the next slide. You could start using it. So the second it's in stage 4, if you think it's awesome, it's going to improve your developer experience, go use it. And I'll show some detail and data in regards to see who implemented it, what the polyfills are, if you will, because mind you, they need 2 major implementations. So your favorite browser of choice might not have done it. And I'll show you examples of that. So just because it's in stage 4 doesn't mean everyone implemented it, but it's good enough to be in the standard, if you will. And they'll have a ton of real world usage experience. And then you'll see those pull requests to the different repos. And then that group will have signed off on it, if you will. But this is when you know that it's considered stable. So now look at this, and there's actually more here. I took this screenshot at least a month ago. So if we look at duplicate named capture groups, well, it was approved in April 2024, but it's not going in until the 2025 standard. Why on earth is that? So if we think about that, they publish this new standard annually, right? And they meet X number of times a year. I believe it's around 6. The new features typically get finalized around January or February. Then they need some time to formally approve that specification. And like back in the day, you could request a full printed version of the ECMAScript specification and they would mail it to you. I don't think they do that anymore. But they need time to get it in. So like there's a cutoff date roughly around February. So this one that was approved in April, it's good. You could start using it. It's just not going to be in the official spec until 2025. And then the standards, published after that. And you can see on the ECMAScript GitHub, you'll kind of see the history of the proposals and when they go in. But like, just because this one's in 2025 versus 2024, you still can start using it, et cetera. It's just when it officially goes into the spec. So yeah, keep that in mind. So I'm going to talk about some different proposals from stage 4. So these are good to use. You can use them and kind of what was added in the latest edition, if you will. So, and I'm also going to talk about some that are not stage 4 as well. So well-formed Unicode strings. So in JavaScript, strings are UTF-16 encoded, which has a concept of surrogate pairs. So there's 2 new methods, is well-formed, and that will return a Boolean indicating whether or not a string would have any lone surrogates if it's well-formed. And then you can then also use toWell-formed, and that method will return a string where all of the lone surrogates, it's going to replace them with a Unicode replacement character in order to make them valid. So if we look at this code example, we have in line 2, we have an example of a string, and that has lone surrogates. We have it before hello and before world. So if we want to say, okay, is that well-formed, you can use the isWellFormed API. So if we look in line 4, you see that call to isWellFormed to say, okay, well, does this string, is it well-formed? And because it has those lone surrogate pairs, it's going to return false. So then if we have a valid surrogate pair in line 8, so that's the rocket ship emoji, checking that. If you wanted to see, is this well-formed, you could call the is well-formed, and then that would be true. Now, let's say that you had an API that needs well-formed surrogate pairs. So if you look at line 13, for example, in code URI, if you have lone surrogate pairs, that's going to fail, if you will. So let's say that I wanted to send the string from line 2 to that API. Well, typically it would fail, but instead what you can do is use that other API that now exists, and then instead take that string with the lone surrogates, and then just call the .to well-formed. So it's a way that you can interact with different APIs that need well-formed surrogate pairs in regards to the UTF. So I'm going to show 2 of these, and there's a purpose. This one, the support's pretty good, right? So if you're not familiar, Can I Use is a platform that will sort of show you the implementations of different features and what the browser compatibility is. So if we look at this, it's stage 4. Most of the major browsers implement it, right? And like there's more browsers to the right that are have less of a market share, but pretty much the latest of all the browsers have it, if you will, and you'll see that. So it's good to use. And typically, and even if it's not, there will be polyfills, et cetera, and those polyfills will be production ready. They'll be pretty performant. They'll have a whole bunch of tests around them, et cetera. They're not experimental. However, this stage 4 proposal, the reason that I put the can I use there, and sorry, like the font's a little bit tiny, is Firefox did not get a chance to implement it. So if most of your customers are on Firefox, you're going to have to use the polyfills or you're going to have to wait to use it. So even though it's stage 4, not everyone implemented it. And you'll see that it's not just Firefox. Sometimes Safari doesn't want to do it. All of the browser engines have their reasons on when to do it and reasons that they're waiting or not. So always look to see that. And remember, what's it take to get from stage 2 or stage 3 to 4? 2 major implementers need to implement it. So this is always possible. So it's always good to kind of see what the support is, if you will, especially if your use of polyfills and browser compatibility matters, if you will. So next, let's talk about atomics.waitAsync. So this is a new static method, and it'll wait asynchronously on a shared memory location and return a promise. So you might be thinking, okay, this is kind of similar to atomics.wait. However, this one is non-blocking, so you could use it on the main thread. So if you're a little bit less familiar with atomics, the way that I think of it is static methods for sort of synchronizing operations between multiple threads. So, well, let's take a step back. What's exactly an atomic operation? It's a piece of work that's indivisible or uninterruptible. And when on earth would you want to use this? It could be useful if you have different operations on multiple threads and you don't want to block the main thread while you're doing things on other threads. So like you might have worker synchronization. Maybe one worker is waiting for a condition to be met by another before proceeding, et cetera. And it's going up, doing a batch process, et cetera. Resource sharing is another one that I can think of. Accessing different shared resources in a multi-threaded environment. There's another addition that was added too, and we can now resize shared array buffers. And the reason that this is useful is it helps out with your memory usage. So before, you would have to, because you couldn't resize a shared array buffer, you would have to kind of guess how much memory you need. So you would either over allocate and be inefficient with your use of memory, or if you accidentally exceeded that memory in the shared array buffer, the way you would mitigate it or fix it is you would have to clone it to another one and then give it more space to the one that you're cloning it. So you're copying it and then you're getting into the same thing of sort of resizing it and oversizing it, if you will. So now the fact that you can resize those, that's beneficial. So let's look at an example here. So if we look at line 1, we have a shared array buffer of 4 bytes. And then in line 2, we'll have the typed array to view that buffer. And then we'll initialize the first element to 0. And then if we quickly jump to line 21, sort of in 2 seconds, what we will do is we'll change the value at index 0 and just change that every 2 seconds, if you will. So then if we look at kind of how does this API work, how does waitAsync work, if we go to the function wait for change on line 7, we kind of look at that. waitAsync has a typed array, an index, a value, and then the timeout is optional, right? And because if it's waiting for so long, you might want to give it a reason to time out after a certain amount of time, especially if you're not sure on how long those processes will take, or that worker maybe your team didn't write, et cetera. But the typed array would view the shared buffer. The index is the position that you're going to wait, and then you'll have a value that you're going to test. So if we look at it, we could see it in line 13, the .waitAsync, and the value, and pretty much the .async, you'll have a Boolean on whether or not the value is a promise or not. So in our case, it is. It's true. So then result.value, if that's true, it's going to have the promise, which is fulfilled with a string value. So in our case, right, and that's either going to be okay or timed out. The promise will never be rejected. So in our case, we go through here in 2 seconds, we're going to wait for that change. And then when we see it, it would return okay with the waitAsync there. Another addition to the standard in stage 4. So good for use, et cetera. Always check the browser compatibility, but like typically if it's in stage 4, someone probably did a polyfill for it. Object.groupBy, and actually, someone probably did a polyfill to the older versions. Firefox not implementing it, you might just be out of luck. Mind you, I think all the major browsers did this one, but like it's always good to kind of see that state, if you will. So object group by allows oneself to group elements of an iterable according to the string values returned from a callback function. And the key to keep in mind with this is it won't change the original object, so it's non-mutating, if you will. So you might be thinking, all right, like, this isn't really like that new or helpful. I could just use Lodash, and you can use Lodash. All of your code using Lodash, it'll still work after this. So it's so the whole goal with these standards is not to break the web. So you don't want to make it so like you can't use Lodash. It's just if you want to use this way, which possibly has a better developer experience, feel free to use this, but without breaking current implementations, if you will. So if we look at this example, we'll have a bunch of artists and then our callback function. So like, we have Taylor Swift, maybe Utah's own Post Malone, different prices, if you will. That callback function, based on the price, will kind of make a guess on whether or not it's a sold out show or maybe there's some value to be had at the show, if you will. And then the bulk of the API or the new change is in line 10. So you could do object.groupBy, send it your value, and then the callback, and then what you'll get is the output below, if you will. So you'll notice sold out with the different elements underneath there, and then value with the different elements under there, which was facilitated by that callback. Now, there's something that's incredibly similar to this, but slightly different, and I'll cover that as well. And that would be array map grouping. So there's a map.groupBy, very similar to object.groupBy, but it groups elements into the map object. So in this example, if we look, we have a bunch of ski resorts, and if you're not familiar, certain ski resorts in Utah do or do not allow snowboarding. So Alta and Deer Valley do not allow snowboarding. And then if we look in lines 8 and 9, we have the two different principles of whether or not snowboarding is allowed. So if we now call this API in line 10, map.groupBy, we can send it the ski resorts, and then whether or not seeing if snowboarding is allowed, and that will group it into a different map object on whether or not the callback is true, whether or not snowboarding was allowed. So then you would get the following outputs in line 14 and 15. So for no snowboarding, you would get the elements that you expect there, and then the opposite, if you will, in line 17. Another one that made it to stage 4 is promise.withResolvers. And actually, before I cover this, I'll just talk about one that's in stage 1, which I decided not to cover. And that's because, in stage 1, it's just a theory, if you will. So there's pattern matching. And it's in stage 1, there's been a lot of different hype for it, and I guess videos and talking about JavaScript's doing it more confusing than other languages. You can kind of look at it and see it on the GitHub page. However, the API is so likely to change. Any of the proposals, they're just theoretical. It'll probably change by the time it gets to stage 3, so it would be ineffective if someone goes back in time, looks at it, and they're like, hey, the API is not even the same. So that's one thing to keep in mind. There's a lot of neat ideas and exciting ones in stage 1. Just realize they're still a living, breathing proposal. You can put your discussions on there, influence maybe how they're changed. Maybe a lot of people agree with your points and they change, but don't get too emotionally attached to them because they're still breathing. Where things in stage 3 and 4 are very well ironed out, if you will. So yeah, let's talk about promise.withResolvers. So this is a new way to interact with promises, and probably the utility of this is if you're going to interact with non-promise-based APIs. So the bulk of this would be line 5, but pretty much what this facilitates is the ability to get the promise, the resolve, and the reject function separately, and then what that would allow you to do is to control when to resolve or reject the promise outside of the executor function, if you will. So if we look at this, similar concept, every second for the timeout, we'll have this go through, and half the time it's going to resolve, half the time it's going to reject. So if we look in line 5, right, we're using promise.withResolvers, and then as a result, I can then take that resolve and I can use it in line 10. I can use it in line 12 as well. So I can use them outside by doing promise with resolvers. And then this would typically work and allow one to do all the actions they normally would with a promise, whether it's further chaining with then or catches, and then just going about and using that promise and handling the resolved or rejected promise when you need to or however you need to. So just possibly a more elegant way in order to go about this workflow. You could do this before by setting different variables and then using them outside. It's just maybe a more efficient or elegant way to do this workflow as a developer, if you will. So this is one that I've been looking forward to for a bit. Temporal, I thought it was going to be a stage 4. It's not yet. You can look into the GitHub discussions. There's different reasons, and so much is thought about with these, like whether it's there's experts from different international time standards, different workflows. Now, mind you, looking at the different workflows, I couldn't think of a workflow with date or time that was not possible, but like so much goes into this. But here's the key thing, right? Even though like you might see this and be like, hey, I really like this a lot more than how I currently have to deal with date times, it's still experimental. So like, even though you might say, okay, well, who wrote it? And like, they're great developers, it's a great organization. Trust them when they say it's experimental. Maybe just play around with it, but maybe not use it in your production code until it actually makes it to stage 4 would be my advice, if you will. But a lot of neat things here. So you used to, date times. Why does something have to be a date time? Where now there's a concept of you could just have a plain date or a plain time. So if we look at this, right, if I just want a date, I don't care about time at all, just a date on a calendar, et cetera. Maybe it's remembering birth dates, et cetera. Line 1, you could just have a plain date. So with a plain date, you could do plain date things. You can add X amount of time. Like, let me add 5 days to a plain date. And then you might have the opposite. All right, I don't care about the date. I just care about the time, like how long it takes me to drive around a track, et cetera. So line 4, just give me a plain time. And then, what might one want to do with a plain time? So you can add hours, seconds, et cetera, to a plain time. Now there's also a concept of, all right, I need a date and a time. So that would be plain date time as shown in line 6, if you will. You can also work with durations as one would expect. So if you have a duration, you can kind of say, okay, X number of hours, minutes, days, et cetera. And then naturally, if you have a date time, you can add a duration to it. So if you want to add some time to a date time or add a duration to a date time, you would have the results like on line 10. You can also compare dates or date times. So just as one might expect, if you're comparing those two dates, date 1 and date 2, you'd get -1 because date 1 is earlier than the latter. And then you can also work with time zones and converting between time zones. And you may not realize this, but there's a lot of like interesting overhead that your browser does or different browsers will do to deal with date times. So for example, like if you have a user in one of those cities, especially in mobile, that's between two different time zones, and they start in one and they go to another one, there's a lot of different logic there to try to handle these edge cases. And you could honestly talk about that for hours, if you will. But when converting between date times now, you could sort of say, okay, well, now, like you could do temporal.now, the time right now, and then give me a date time for whatever time zone that you're currently in. So let's say you're in London in line 18, and then you could say, okay, well, I was in London, but now convert this time to New York because maybe you're going to try to order a pizza from New York and you need to know if it's open. So then you would just do with the time zone and switch the time zone. You can also calculate the difference between two different dates. So if you have two different dates, like we do in 22 and line 23, you can see what the diff is and then just do, the start until the end, and then you would kind of see that. And the format, if you're not familiar with the ISO 8601 standard, the reason that you have the P there is because that's the pyramid, so it's 366 days because there's a leap year in there. but that's sort of what the P is in the ISO standards. And then most importantly, if you're like, okay, well, like, I don't really care about the ISO standards, there's so much you can do with the formatting, if you will. So like you could say, okay, like in line 27, how to like format your dates, if you will. Give me the full format, the time style, do it long, and then set it to a certain time zone and do that. And there's an immense amount you can do with the formatting. I think there's easily like 80 lines of examples for the formatting on the GitHub proposal. So I wanted to mention that, if you will. And then something else that's pretty neat is new set methods. I put the star here for stage 4 because even though it was added, it won't come out, I think, until 2025, but this is pretty neat. So 2 things, right? And to illustrate this, and my apologies to the people all the way on the top if the font's a little bit small. So these diagrams for the different set methods that they did, they came from MDN. Mozilla does a great job of their developer network docs to demonstrate different concepts. So if you're ever wondering like, hey, how do I use this new API, et cetera, typically their docs are pretty good. I use their visualizations on the right because I didn't want to make them myself, and I thought they were pretty good. But we'll have these new set methods. So just as a refresher, if you don't remember what a set is, it only has unique elements. So for example, if I have that set 1, 4, and 23, I can't add 23 again. So the different set methods that will be included are different. Like let's say like what's different between one set and another set, the intersection, where do things overlap? So like if I have people at Utah.js and I have people at Atlanta.js, who went to both, who spoke at both, et cetera, that would be like the intersection, a symmetric difference, if you will. So that would be who are, of 2 different sets, who are uniquely in those and don't overlap. The union, the inclusion of everything from one set or another, and then disjoint sets and subsets, if you will, and supersets. So if you think about like, when on earth would you use this? I could think of a couple examples. One, if anybody's in e-commerce, understanding different users and purchases, like, hey, who purchased the PS5 Pro but did not purchase the original PS5? Maybe you want to do some targeted marketing. That would be useful for different sets. A lot of times, there's a lot of set manipulation on the back end. So neat to see this coming to JavaScript. Another one that I can think of that's sometimes pretty prevalent is role-based access control. A lot of times different groups make different roles for security permissions of people who are similar, they're overlapping, and you can have some like weird logic because of that. Now with these different set methods, you can maybe more efficiently look at the differences between different sets for role-based access control and kind of go about that for how you did permissions with maybe a little bit less code and a little bit less convoluted code. Yeah, thanks a ton for your time. Really appreciate everybody being here. Yeah, thanks.